Hey guys, today won't be a lead code question. I'll be teaching logic laws, which is a part of the discrete maths curriculum. And I'll be solving two questions, and I'll also go over the logic rules. I would heavily recommend just memorizing them for your exam. They are pretty useful, and if your professor also mention about writing down the rule you got used to get to your assumption. So these are predicates, by the way, and we have to land at some assumption by using these predicates. So sometimes they would want, okay, from arguments 1 and 3 you use modus tollens, and then you got some x4, let's say. So it would be helpful to memorize it with names. If not, just memorize them as is, but I would definitely recommend memorizing them. I'll just talk about them briefly in English, and then I'll solve the question so that you can see my thought process. Modus ponens: if P then Q, and then we have a P, that means P occurred. And by literal definition, if P then Q, and if we have P, then obviously Q will happen. That's pretty self-explanatory. Modus tollens is actually based off contrapositive, I would say, P to Q, if you don't have Q. So if you've done proof by contrapositive, proof by contradiction, you will see if P then Q, the opposite of that could be if not Q then not P, and it's basically that. So if we have not Q, then we would say not P, and we would basically get not P. Hypothetical syllogism: this one is pretty useful. This is one of the most useful ones. Hypothetical: if P then Q and Q to R. So if P, then we get Q, then we get R, right? So directly we can write P to R. I'll show you this in the question that I'll solve. It's very useful. Disjunctive syllogism: PVQ not P, so it's either P or Q, right? And if not P, then obviously Q. That's pretty self-explanatory. Addition is pretty rare to come across, but it is useful. Sometimes it can help you get out of extremely tricky questions. You can just add basically something out of these predicates that you're given, let's say U or T, right? Very rare though. I would suggest not using it, because usually you could find a way to do it with the given predicates. Use it as a last resort, I would say. Simplification: P and Q, you can simply write that as P or Q, like P or Q, as in the assumptions P or Q. Conjunction: if we have P, if we have Q, then we can write P and Q the opposite. These two are opposite of each other, you could say. Resolution: that's also very important. PVQ not PVR, then we can write QVR, because not, you can just see P and not P, and then you can write QVR. You can memorize the pattern here. You have 1 2, you have 1 negated, and then you can simply take the right hand side of these two elements and then write a or in between them. That works. Now I'll show you how I approach logic questions. So let's talk about question 1. Okay, so I'll give you 2 seconds. Think of the first rule that comes to your mind. 1 2. Okay, I hope you came up with hypothetical syllogism, right? If you look at these, PVQ to R, R to S, and S to T. What does that repeat? The same thing. Hypothetical syllogism: P to Q, Q to R, then P to R, right? So we can simplify these two to S, then we would have S to T. To simplify these two, PVQ to T. Now our statement 4, not T. Now what was it? So modus tollens, I'll just tell you that. When you see a direction Like if you see if P then Q and then you see a knot happening to the right hand side, immediately modus tollens, because you have to think contrapositive, stuff like that, right? So you come down here, then you say if not T, then not P V Q. Then with this you can say not P and not Q. This is by De Morgan's law. So that is the negation law. If you have not P and Q, you can negate the P, you can do the opposite of OR, which is the and then do this. If you had a, it would be the same, except you would just do this. Okay, now we can use simplification. Our assumption is this, by the way, not P. We can literally just use simplification. We would get not P or not Q as our this thing, right? But we'll just take not P to simplify and finish off the answer. We'll say simplification. And that's it, literally. We used the same, hypothetical syllogism 3 times. 1 modus tollens, 1 De Morgan's, and then 1 simplification. We're done. Now for question number 2. Messed that up, but let me just bring it over here. Give you extra time to think, honestly. Okay. Again, if you thought hypothetical syllogism, very good. P to Q, Q to R, R to S. So what does that bring? P to R, R to S. We can write P to S, right? Now take these two. T to U, U to S. You can write that as T to S, right? Now P to S, T to S, and we also have, what do we think? Yeah, PVT. Okay, so we have these two. We can basically say, where is it? Did I not? This. Yeah, we can say disjunction. Did I write that? No, okay. So we can say by disjunction, or you can explain it in simple English. There's another rule, disjunction, which you can look up. But there is another rule that you can just say it in English. If P or T, and if P also gives us S or and T also gives us S, then if either one is true, we would always get S, which is just the assumption. I'll actually look up the disjunction rule just to show it to you. Okay, yeah, disjunction introduction. So it basically states P or Q, if at least one of it is known to be true, then that is true. Basically, that's what it just states. So yeah, you can just write that in simple English and you can get S as your assumption. You can just state disjunction. That's it pretty much. I would just recommend, just memorize this before your exams. That's the best thing to do.